In our last video, we covered the Pearson's rank correlation coefficient. And so what happens if we're actually given the data already ranked? Let's take a look right now. So let's say the student was asked to rank 9 different makes of burgers in terms of what she liked best and what she liked least. So 1 for what she liked the best and 9 for what she liked the least. And then these rankings are given down there, as well as the cost. So we're looking to see if there's a relationship between the perceived quality or the perceived preference in the quality of a hamburger and the cost. And boy, would I love to be a subject in this test. Love hamburgers. Now let's explain why we can't use Pearson's in this example. Like what they mean is, why can't we use the product moment correlation coefficient? Well, that's because the rank is already given to us. One of our data points is already ranked just by the very nature of what this study was trying to do. So this actually makes the first part really easy because we just can copy this down. The rank is already done for us. Okay. So now what we got to do is rank the cost, because since that we are given the taste as a rank, we are actually left with no other choice but to use the Pearson's rank correlation coefficient. So it's not that this is any different, it's just that we actually have to use it now, rather than being like an additional tool. But again, remember that if it's a nonlinear, as long as there's no squiggle, you can use it if it's monotonic. But again, it's used for nonlinear relationships, but also any kind of data set that is given to us as a rank already. So how are we going to rank all of these burgers? Well, we're going to start off with the most expensive. And the most expensive burger is this one at $8.50. Okay, and then I'm going to see that the next one's going to be $7.45. That's going to be 2. And hopefully after you realize kind of like the pattern and looking, sometimes it helps to cross these off on an exam just so you know what you've already covered. But you'll go ahead and you'll end up with 7 over here, 2, 3, 4, 1, 8. Absolutely not glancing over to my answer key. That would never happen. There we go, 9. So now what we're going to do is we're going to take this data, put it into our list and spreadsheets, and see what we can determine. So go over to our list and spreadsheets. I have taste, which I'm denoting as X, and I have cost, which is Y, which is kind of funny. Imagine it was tasty, costy, I don't know. I found it funny. Either way, we have the ranks all here. And again, we'll go to that C1 value without a blinking. We'll do our stat calculations, and we'll go ahead and do linear regression. And I'll put the taste as the X. I'll put the Y as the cost, or the costy. And I'll find that my R is 0.8. So my R is 0.8. I go back over here. I will say that my R is equal to 0.8. So comment on your answer. What this does is it suggests that there's a pretty moderately strong relationship. I guess at 0.8 you could argue that it's not moderately strong, it's strongly strong. Either way, there's definitely a positive correlation for sure. But I would go ahead and say moderate or strong, depending on how you want to define that 0.8. It's kind of not really a gray area, but you get what I mean. But basically what it's saying is that there is a moderate or strong relationship, positive relationship, indicating that the more expensive a burger is, the more tasty it is likely to be. So again, we are given a ranked set of data already, and all we have to do is rank our other variable, put that into the spreadsheet like we did before, do the regression as we've done before, find the R value as we've done before, and there we go. We made the same type of comments. So that's what we do when we're given a variable that is already ranked. In this case, we have to use the the Spearman's rank correlation coefficient. That's all I have. Goodbye.